Back in 12.3, we talked about the relationship between cones and pyramids. We said that basically a cone is like a circular pyramid. It's like a pyramid, but it has a circular base. So in terms of like finding areas, volumes, whatever that might be, if we're looking for perimeter of that base, we're just going to use our circumference formula because that's the perimeter of a circle. If we're looking for area, we're going to use that pi r squared because that's area of a circle. So the volume formula for a cone is going to be identical to the volume formula of a pyramid. They're going to take up the same amount of space. Oops. So that'll be 1/3 area of my base times my height. The only difference is that formula is going to be pi r squared. Now we still need to have the height, not the slant height. So this is one of those curveball questions like the last one where we have to find that height. So we're going to draw in a right triangle. That ought to hit the center of my circle. Now if this diameter is 30, that makes this 15, and this h. Okay, so we've done this a bajillion times this year. H squared plus 15 squared is the same as 25 squared. Make sure you don't take the square root of this minus the square root of that. You're not allowed to do this. Something I see a lot. The square root of a minus b does not equal the square root of a minus the square root of b. You're not allowed to do that. So be careful not to make that mistake. We'll go ahead and plug those into our calculator. See that minus that. I get 400, which means it should be 20 centimeters. Now, if you remember your Pythagorean triples, this is 3 times 5. This is 5 times 5, so this should be 4 times 5. That's a 3, 4, 5 pattern there. So you come out with 4 times 5 is 20. So now we have everything that we need. Volume will be 1/3 of pi r squared, so the radius is 15. It's 225 when you square it. So 15 squared pi times the height of 20. And 225 divides by 3, 75 times. So if you want to write this in as reduced form as possible, that'd be 1500 pi centimeters cubed. The way I got that was I took 1/3 of 225 and then I multiplied it by 70, or sorry, by 20. So I got 75 and then I multiplied by 20. Typically we round off, and if you plug that into your calculator, you get some pretty close to 4,712. They should tell you how to round. That's cubic centimeters, not squared. So volume of a cone, identical to volume of a pyramid. Next, we're going to take a look at an oblique cone. Remember, oblique solids have the same volume as what we call right solids. So just because this thing is slanted doesn't mean it's going to take up any less space as a cone that isn't slanted. So this is actually our height. And this looks like a really hard problem, but actually you pretty much plug in everything you have. Volume is 1/3 area of base times height. Well, if that has a radius of 6, square that, you get 36 pi times 22. And again, how we got that was pi r squared, and the radius is 6 there. Let's see, if you reduce that thing, that comes out to be 264 pi feet cubed. And as always, we've been seeing here, our rounding comes out to be about 829. Say if we go to the nearest tenth, 0.4. Either or. Now I'm using that pi button in my calculator. If you use 3.14, you're going to get something really close, but not quite the same. So oblique, remember that term. That just means it's kind of tilted or slanted. It doesn't mean it's so bleak or dark or hopeless. No, sorry. They're just cones or pyramids that are slanted, also prisms. Last example I have for you guys is something called a composite solid. Just like composite figures where we found area, that's whenever you combine multiple solids. So we combine like triangles and polygons and other things. Here we're just combining different solids. So what I have here is a cylinder that's stacked underneath a cone, and it looks like they have the same base, so they're gonna have the same radius. I'm gonna have to find the volume of this plus the volume of that, because I'm looking at how much space does this take up plus however much space this takes up. Now, if this was a surface area question, it'd be really tricky, because with surface area, I would really only look at the lateral area of my cone, the lateral area of my cylinder, and then one of those bases. Think whenever they ask you the question about surface area, think of if you're going to cover it with something, like if you're going to paint it, you want to figure out how much paint you're going to use or what you're going to cover with paint. That would be an area or a surface area problem. So like if they wanted us to paint over this thing, we would paint over the lateral part of the cone, the lateral part of the cylinder, and then maybe the bottom part of that cylinder. We wouldn't disconnect these things and then paint the bases and then reconnect them. That wouldn't really make any sense. But volume is a little bit more intuitive. You just do volume of this plus the volume of this. So I'm going to do the volume of my cone in green. I need a height, just like that last one. If this is 10, radius is 5. So volume, 1/3 area of that base times that height. And let's see, we need to find height. I'm going to do that over here to the side, actually over here. So Pythagorean theorem. This should be one of those triples. Hopefully you all remember. It's 169 minus 25. And so when you take the square root there, you get a 12. And that's one of our triples. It's a 5, 12, 13 triangle, if you remember that. If you wanted to skip all of this work, that is fine by me, as long as you said something like h equals 12, and you tell me that's a 5, 12, 13. As long as you put that on there, I'm okay with that. That tells me you remembered your Pythagorean triple. If you don't show me that, then I'll say, how did you come up with that? You got to show either the Pythagorean theorem or that you remembered that pattern. Either one of those is totally acceptable. So a third, the radius is 5. 5 squared is 25. And we found the height was 12. A third of 12 is 4, so that comes out to be 100 pi. I'm going to leave that alone for now. So say yards cubed. And then I'm going to look at the volume of this cylinder down here. Volume is just area of base times height. We don't take a third because this is a cylinder, not a cone or a pyramid. Oh geez, that's same radius of 5. 25 pi is that area of my base. This one has a height of 5. That's the distance between my bases. So that is 125 pi. Okay, so my total volume, I'm going to pump up the volume on this one. Total volume comes out to be the sum of these two, which is 225 pi cubic yards. And I think we just did that same value in our calculator. No, it was 264. Let's see. Comes out to be pretty close to 707. Alright, so I'm not going to spend too much time with videos today because the formula is almost identical to the one we saw last time. Instead of capital B times H, we just have an extra factor of a 1/3. So same formula as your prism, you just take a third of that thing.